Welcome all of my geometry students and all the ones in other classes. This is the review for the Section 8 test. And we'll go ahead and get started. So the first question, match the correct ratio with the trigonometric description using the triangle below. So all of these is asking for sine of C, cosine of C, and tangent of C. So C is our angle of interest. So I'll just want to circle this so I know which one to focus on. And then sine, so remember we want to use the acronym SOHCAHTOA. So make sure you say it's SOHCAHTOA, not SOHCAHTOA. It's S. So sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. So if I'm looking at sine of C, I want the opposite over the hypotenuse. So the opposite is going to be across from my angle of interest. So that would be 15. So 15 would be the opposite. So opposite over hypotenuse equals 15 over the hypotenuse is the side opposite the right angle, so 17. Cosine is going to be adjacent over hypotenuse, and adjacent is going to be, adjacent means next to, so adjacent is going to be 8. Next to, so that's adjacent to my angle of interest, so it'll be 8 over hypotenuse again is the same, 17. And tangent is opposite over adjacent, and so opposite of C would be 15, and opposite of C would be 15, and adjacent to C would be 8. So 15 17ths, 8 17ths, and then tangent is 15 eighths. Okay, the three sides of a triangle are given. Determine if the triangle is acute, right, or obtuse. So you just need to know what the rule is for this. So if it's a right triangle, so if it's right, it's a squared plus b squared equals c squared. If it's acute, if you think about it, the legs are really long legs and a short hypotenuse, so it would be a squared plus b squared is greater than c squared. So this is the hypotenuse, so this would be really long legs, longer legs than your hypotenuse. That gives you an acute angle, okay? And then if it was obtuse, you'd have a really big hypotenuse and short little legs, so a squared plus b squared is less than c squared. So this just means that your legs squared and summed together are less than your hypotenuse. So you might need a calculator for this. So at 7 squared, so I'm going to square these. So 7 squared is 49 plus 24 squared is 576, and then I'm comparing that to 25 squared, and 25 squared it's equal, because 25 squared is 625. So, and this is 625. So that's a right triangle. So if it's equal, it's a right triangle. Alright, the next one is a little test maybe on your fraction knowledge. So 3/5 squared plus 2/10 squared. What is the relationship with 3/10 squared? And I think just to make it a little bit easier so you can compare apples and apples, this is this equal? I'm not sure. So I'm going to change this into, instead of 3/5, I'm going to change it into 6/10. So I'm going to say 6/10 squared plus 2/10 squared. Does that equal 3/10 squared? Okay, and when you square a fraction, so again, remember this, I just changed the denominator of this by multiplying the top and bottom by 2. So that gave me 6/10. That's how I got 6/10 here. So this squared would be 36/100 plus 2 squared is 4, 10 squared is 100, and is this, what is the relationship between this and 9/10? Okay, so 36 plus 4 is definitely, it's larger. That's 40/10. That's larger than 9/10. So my little legs, or my legs are longer than my hypotenuse squared, so this is an acute triangle. 10 squared is 100 plus 14 squared. So 14 squared is, let's see, what is that? That's 196. And then we don't know the relationship between that and 18 squared. 18 squared is 324. So 100 plus 196. So that's 296, and that's less than 324. So that would mean that the hypotenuse is larger than the legs, the sum of the legs squared. So this would be obtuse. Okay. And the last one, so you have to be careful when it's a decimal. Don't just look at it, maybe go ahead and use your calculator. So 28 squared is, so let's see, 28 squared, so 0.28 squared plus 0.92 squared. Is this greater than or equal, or less than 1 squared, and 1 squared, of course, so this is 0.0784 plus 0.92 squared. 0.92 squared is 0.8464, and then 1 squared, of course, is 1. So 0.8464 plus 0.0784 is 0.92. So this is less than. This is 0.92. This is 0.9248 is less than 1. Okay, so if the little legs are less than the hypotenuse, that means it's an obtuse. Okay, the hypotenuse is longer than the legs. Okay. Okay, the highways forming 3 cities form a right triangle. Walnut Grove is 80 miles from Pecan City and 64.1 miles from Almondale. Pecan City is 54.3 miles from Almondale. The road is being planned to connect Almondale to the highway running between Walnut Grove and Pecan City. Okay, so I have 3 distances, which are going to be the 3 sides of my triangle. And I know from doing a lot of these problems, we've practiced a lot in class, that this must be the hypotenuse. It's the longest side. So I know I'm forming a right triangle, so I'm just going to draw out my first triangle. So I'm going to draw a side, and then I'm going to draw my hypotenuse. And I want to make this as extreme as possible to be able to see the difference between my small, medium, and large triangle. So this is my overall picture. So I'm going from Walnut Grove, I'm going to call that W, to Pecan City, I'm going to call that P, and that's 80 miles. And Pecan City and Almondale, that's my third place, is 64.1. And Pecan City and Almondale, Pecan City, oh, whoops, I made a mistake. So, sorry. Walnut Grove is 80, right, from Pecan City, and Walnut Grove is 64 from Almondale. Okay. So I want to change this around. So let's see. Actually, let's just start over again. Whoop. All right, here we go. Because I already drew my hypotenuse, so this is going to be my long side. So my long side is 64.1. There we go. My hypotenuse, so then this is my short side. This is 54.3, and my hypotenuse, okay, my hypotenuse is 80. There we go. And so I have, this is, just check it, Walnut Grove is 80 miles from Pecan City and 64 miles from Almonddale. There we go. That looks more accurate. You can see that this first one, this is supposed to be my long distance, but ended up being, it looks short, so that's why I wanted to redraw it. Alright, so, and I am trying to draw the shortest length possible for my road across. It says the shortest road possible will be blank miles. So I'm trying to draw from my right triangle, I'm drawing an altitude to my hypotenuse. And so I'm just going to draw that. So it needs to be perpendicular, so I'm going to go like this. Okay, and this is my distance, so we'll call that my distance. So I have, in my class, we've been doing the 3 triangles, so there's the big triangle and then the 2 triangles, okay? And so I'm just going to draw the medium triangle and the large triangle as well. So I'm going to draw this. So this is my large triangle first. So this is 80, 64.1, and 54.3. And then I'm going to do, let's see, I'll do my medium triangle. So in my medium triangle, it's going to be this triangle here. Alright, and let's see, so that is, so what is the, we have to look at my medium triangle. My medium triangle, the hypotenuse, is 64.1, okay, because this is a right angle, so across from my right angle is my hypotenuse. And then my short leg is my distance. My short leg is my distance. And my long leg, I don't know. So we have enough to use triangle similarity to solve for D. So the short leg, D, okay, is related or is similar, proportional to the short leg of the large triangle. This is my medium triangle, so that's 54.3, and that's proportional to my hypotenuse, 64.1 over my hypotenuse of 80. And then you just multiply both sides by 54.3, and you get, that cancels out, and so you get 64.1 times 54.3, and I'm going to divide that by 80. And that's, my distance is equal to 43 point, we'll say it's, what they say, the shortest will be blank miles. Round your answer to the nearest tenth. Okay, so 43.5. Number 4, a 10-foot ladder is propped against a vertical wall and makes a 63-degree angle with the ground. How far is the foot of the ladder from the base of the wall? So if we have wall here, and then we have our ladder, this is our 10-foot ladder, like that, okay? And then we want to know how far is it away from the wall. So we're looking for this distance x, and it said this is 63 degrees. That's the angle the ladder makes with the wall. That's the wall. Okay. So, there we go. Alright, not to be confused with the ladder. Right. Okay. So, I'm missing, so again, I want to think about SOHCAHTOA. So I'm missing the side adjacent to my angle. So adjacent, and I have my hypotenuse, so I have adjacent over hypotenuse. So I'm going to use cosine of 63 degrees equals, again, adjacent x over 10. I'm going to isolate x by multiplying both sides by 10. 10's cancel out, and you just, in your calculator, you do 10 cosine 63. And x equals 4 point, it says round to the nearest tenth, so 4.5 feet. Okay. So students were asked to find the value of x in the figure. Which equations below could be used to solve for x? Where is the x in the figure? Let's see. Alright, I've figured it out. There's a missing x on the hypotenuse. That makes sense. So students were asked to find the value of x in the figure, the hypotenuse, which equations below could be used to solve for x. So I'm looking for x, so if I use cosine of 43 degrees, so I don't see any 43 degrees on here. Well, I know this is a right triangle. If this is 47, then this must be 43, because 47 plus 43, right, is 90, plus 90 degrees is 180. So cosine of 43 degrees. So if this is my angle of interest right here, okay, and I want cosine, that would be my adjacent over my hypotenuse. That'd be 15 over x. So that's 15 over x. That's that one. The sine of 43 degrees. So that's going to be opposite of my 43 degree angle, my angle of interest, over hypotenuse. That's 8 over x. Alright, now if my angle of interest changes to the 47, which is the top number, top angle up here, then cosine of 47 is going to be adjacent, so that's 8 over x. And then if I'm looking at sine of 47, so again my angle of interest, the opposite is 15 over x. So 15 over x. Okay. Okay, for the next problem, we did not do any practice on it, so but on page 196 on example or problem 2 in your workbook, they tell you that or they allude to the fact that when comparing two acute angles, the sine of one is equal to the cosine of the other. Remember, if we talked about this in my class, if we're looking at a triangle, the sine of one would be the cosine of another angle, and these are your acute angles in the triangle. Anyway, we did not go over this very much, but I'll just kind of give you the quick and dirty on how you're going to solve this problem. So I wrote here, sine of one angle must be equal to the cosine of another angle, and we're talking about the two acute angles of a right triangle, so this angle and this angle. And so these angles must be complementary, right? They must equal 90 degrees. Okay? So if sine of one must equal the cosine of another, then that means that what's in here, okay, what's within the parentheses, they must be complementary. In other words, 18m minus 12 is equal, or sorry, nope, not equal, plus 7m plus 2 must equal 90 degrees because they are complementary. Remember, complementary angles add up to 90 degrees. Then you combine like terms, 18m and 7m. So 18 plus 7 is 25m, and then minus 12 plus 2 is minus 10, and that equals 90. Okay, and then let's see here. So then I'm going to add 10, and we get 25m is equal to 100. We divide by, oops, that's 25m. Divide by 25, divide by 25, m equals 4. So m equals 4. Okay. Again, not one that we've practiced. So a wire is attached to the top of a 53-foot telephone pole and anchored to the ground. The angle of elevation is 61 degrees. So elevation means from level up. That's angle of elevation. It's your level up. So that's 61 degrees. They even drew it for you. How long is the wire to the nearest foot? So we're just solving for a hypotenuse. And it looks like we have the opposite side. So I'm going to use sine of 61 degrees is equal to opposite 53 over x. I'm calling that x. So You can solve this however you like. I'm going to multiply both sides by x. That cancels out. I get x sine of 61 degrees equals 53. Then I'm going to divide by sine on both sides. I'm trying to isolate x. 61 divide by sine of 61 degrees. And the sine 61s cancel out, so x is equal to 53 divided by the sine of 61. So I just take my calculator and I go 53 divided by the sine of 61. So it's 60 point, and they say round to the nearest foot. So that would be 61 feet. X equals 61 feet. Okay. Find the value of x and y rounded to the nearest tenth for the figure on the right. Okay, so I'm looking for x and y, and I can see that I have a 45, 45, 90, so this is 90, and then a 30, 60, so I'm going to put 60 here, and this is a 90. This must also be a 45. Alright, so I'm going to start with the information I have, and then work my way around. So if this, remember, again, if I have a 30, 60, 90, it's short, which is opposite of the 30. This is too short, and this is short square root 3. Again, this is for 30, 60, 90. And then for a 45, 45, 90, it's 1 root 2. So I'm going to start with my 30, 60, 90. So if this is 30, this is my short side. So this is my small angle. This is my short side. So if my 2s equals 44, then my short side must equal, this length here must equal 22, which means that my my base of this must be 22. So this piece right here must be 22 square root 3. Okay, and if this is 22, then this is also 22. And if this is 22 and this is 22, remember to get from my short side, or my leg to my hypotenuse on a 45, 45, 90, I multiply by square root 2. So this is 22 root 2. So it looks like for x, they want you to find the value of x and y rounded to the nearest tenth. So they actually don't want you to write it in radical form. They want you to write it in decimal form. So I'm going to just do the root of 2, hit enter, make sure you hit enter, and then multiply by 22. That's 31.11. I could have also done 22 square root 2, and it would give me 31, the same answer, 0.11, instead to the nearest tenth. So x is 31.1. And now I need y, so y is going to be the addition of 22 and 22 square root 3. So I'm just going to add 22 to my 31. So that's 53.1. A rope is tied to the bottom of a hot air balloon as shown. Okay. The altitude of the balloon is 50 feet. Oops. 50 feet, and the rope is 75 feet long. That's funny. That's different than our picture. Must be a typo there. So it must be 80 feet long. 80 feet long. And this must be 30 feet. Okay. Now, so once we've made those changes, so match it to the picture. So this is 80 and this is 30 and this is an angle. What is the angle that the rope makes? So it looks like I have opposite. I'm looking for this angle here. This is my angle of interest. I have opposite over hypotenuse. So I'm going to use the sine of theta. That's just a way of writing an angle you don't know. Is equal to 30 over 80. And remember, when I'm solving for angles, if I don't know the angle, I need to use the inverse trig function. So it's sine inverse of, and then I use the ratio, 30 over 80 equals. So again, I'm going to use not sine, but the inverse of sine, that's sine to the -1 on your calculator, of the ratio, the trig ratio, 30 over 80. Okay, that's 22, and it says round the angle to the nearest angle. So I guess that would be 22. 22 degrees. In the center of town, there's a square park with an area of 1,600 feet. Okay, I have a square park. And it's 1,600 feet. So if it's square feet, how much is each side? Well, I have to take the square root of 1,600 to know what one side is, because the whole thing is 1,600. So if you should know this, but you can also do it on your calculator. You can take the square root of 1,600, and that's 40, right? 40 times 40 is 1,600. So that means that each side is 40. And if Stephen walks from one corner of the park to the opposite corner, how far does he walk? So that's supposed to be a straight line. So if this is a square, that means in a square each angle is 90 degrees, meaning half of 90 degrees would be 45 and 45. So this is a 45, 45, 90, which means that the distance, if this is 40, the distance is going to be 40. And to get, remember, back up to our picture up here, to get from a leg to a hypotenuse on a 45, 45, 90, we multiply by the square root of 2. So I'm just going to take 40 and multiply by the square root of 2. So 40 square root 2. And so Stephen walks blank. I don't know what this means. We can get rid of that. So he walks round to the nearest foot. Okay, so it sounds like they want us to take this out of the radical. So we're going to do 40 square root 2. So that's 56.56, which means it would be 57 if we're doing it to the nearest foot. 57. Okay. Now we have a figure, so find the side lengths of DC. So they're asking about figures way over here, DC, and the angle measure for ADE. So question mark down in there. Okay. All right, so we have a quadrilateral, all right, and we know that any quadrilateral, the angles, the interior angles must add up to 360. Okay, so total, so for a quad, angles equal 360. And I have, if this bisects this angle down here, so I have one angle, this would be identical to that. Okay, so 1, 2, 3, 4, 5, 6 of the exact same size of angles. So if I take 360 and divide it by 6, okay, that gives me 60 degrees. So each one that looks like this is 60 degrees. Okay, so that means that this is going to be 60 degrees here, which means if this is 60 degrees here and this is 90 degrees, 60 and 90, right, is 150. That means this must be a 30-degree angle. So it's a 30-degree angle, so I can get rid of all the answers that don't have 30 degrees. Get rid of that, and that, and that, and that, and that leaves me with 2 left. And then I know, what else do I know about this? I think I'm missing some information. Some information came off with a little picture. You will be given the length. Oh, that's what this was. So segment from up above. AE is 7 units. Oops. So that comes from right here. So AE is 7. Okay, this is 7 units. All right, so if we have a 30, 60, 90, that means that if we're looking at just this triangle right here, this is your 30, so opposite of your 30 is your short. So if we go from the short side to the hypotenuse, this should be 14. Okay? And that's not an answer choice. So we need to change one of these answer choices. So the answer is 14 units. If this is 14, then this must also be 14. And let's see. And then what else do we have? We have the angle down here is 30 degrees. And so angle ADE equals 30 degrees. Okay. Lexi wants to walk from the parking lot through the forest to the clearing. So from the parking lot through the forest to the clearing. She wants to walk here, as shown in the diagram. She knows that the forest ranger station is 120 feet from the flagpole. The forest ranger station is 120 feet from the flagpole, and the flagpole is 450 feet from the clearing. How far is the parking lot from the clearing? How far is the parking lot from the clearing? Okay. So if you can see this, this is the boomerang. So I'm going to turn this around just for a second while I draw the boomerang. So we know that, so we're going to sit our triangle on its hypotenuse, and we know the length from, so we have a right triangle with an altitude, and we know that this is a right angle. It said it was a right angle here also. So when we know each piece of the hypotenuse, the two pieces of the hypotenuse, from the altitude to one leg and from the altitude to the other leg, then we can use the boomerang. And the boomerang looks like this. So we're going to go, we want to find, this is our distance we don't know. So we're going to use this, and we put it over that, and then that comes back down, and we go almost all the way. Okay, a little messy, but that's the boomerang. Remember, to use the boomerang, your hypotenuse, your triangle has to be sitting on its hypotenuse. So, again, now that the picture's very messy, I'm going to, because I'm looking for the distance from the parking lot to the clearing, this is my question mark, this distance here. So I have to go the whole distance. Okay, so the whole distance is 120 and 450, so that's 550, 570. So it's 570. So we just set it up. So, and I'm going to call this distance D that we don't know. So 570 over D is equal to D over 450. And then we cross multiply. So we get D times D is D squared is equal to 570 times 450. So D equals, I cannot do that in my head, so 570, let's put it over here, 570 times 450. And that equals a big number, so D squared equals 256,500, and we're going to take the square root of both sides, so square root, second root, second answer, that's 506. So D equals 506.5. And it said, we don't know about rounding, so we'll leave it like that. Feet. Okay, last but not least, as a part of their weather unit, CLARS, now I'm teaching science apparently, class took a hot air balloon ride as they passed over a fenced field. So it's a little hard to see this picture in here. But as they passed over a fenced field, the angle of depression, so again, if you're at level, depression is pushed down. So the angle of depression as of the closer side of the fence was 42 degrees. So we have a field, and the closer side of the fence, so if the hot air balloon's here, right, you drop right down, the closer side, so this is our pasture, it has a fence around it, right, not going to draw the whole thing, blah, blah, blah. Okay, so the closer side of this pasture is going to be the larger angle, where the further side of the pasture, so if you remember, we can use what we know about, remember this is alternate interior angles, so that means this little angle here is that's a 23, and then this angle here, so we're looking at the other angle, so the bigger angle, this one, is 42. Okay, 42 degrees. Okay, so we have essentially two triangles here. We have this triangle, and then we have the outer triangle. Okay, so I can just draw that again. We have the inner triangle, which is 42 degrees, and then we have the one on top of it. I'm going to draw it a little bit more extreme though. This one's 23 degrees, and this is our pasture. Okay, and we want to know the length of the pasture. So essentially what we can do is we can just we can find the length of the whole thing, so of the triangle, the big triangle, right, this bigger triangle, and find the length of the bottom, right, of the side adjacent, and then you can find the length of the adjacent side when it's 42 degrees, and you can subtract the two. Okay, so this is a 42 and this is 23, and then we can subtract the two, and both of them have 900 feet here, and we don't know this, so this is the short distance, and we'll call this the long distance. Doesn't matter. So we're just going to set this up. Oops, sorry. So if I'm going to solve for the adjacent side, I'm going to use tangent of 42 is equal to, this is, I don't know, right? So that's the adjacent, and this is our 900. So tangent is opposite over adjacent, so it's 900 over, we'll say the short, and then this one would be tangent of 42 is equal to 900 opposite over, I don't know, the long side. Okay, this is how I'm going to find the difference between the length of the field. So I just need to solve both of these for their variables and then subtract them. So I'm going to move this one up here. So tangent of 42 equals 900 over short, multiply both sides by short, that cancels out, my s cancels out, and then divide both sides by tangent of 42, tangent of 42. So I get, those cancel out. So I get s, the short side to the short side of the field is 900 divided by the tangent of 42, and then it would be the same thing for here, so I'm going to multiply both sides by L and divide both sides by the tangent of 42 degrees, and that cancels out. So my long side, to get to the long side of the field, is going to be 900 divided by the tangent of 42 degrees. Okay, so take your calculator, clear it out, 900 divided by the tangent of 42. This looks like it's, we'll call that 1,000 feet. Okay? And then the other one, so 900 divided by the tangent of 42. What's going on? Oh, I used the exact same. Oh no. what happened? Oh, I used the same, goodness. I used the same degrees in here as I did before. So this should have been 23 degrees. Oh no. Pregnancy brain. 23 degrees. That should have been 23 degrees. This should have been 23 degrees. Oh gosh. Okay, right? That said 23. I should have put 23 in here and 23 in here. That's why I got the same answer. Dits. Okay. 900 divided by the tangent of 23 degrees is, the long length is 2,120. Okay, so what is the length of the field here? Well, the whole distance, right, is 2,120 feet to the end of the pasture. To the short side of the pasture, it's 1,000 feet. So the length of the pasture, or the width of the pasture, this right here, the width of the pasture is the width of the pasture is equal to 2120 minus 1,000. So that's equal to 1,120 feet. So that's your final answer. Just another comment, you want to make sure whenever you're doing anything in our geometry class and trigonometry, you want to make sure your mode is in degrees so that you don't mess up. It must be in degrees. Must, must, must. So you make sure that's highlighted and you hit enter. Okay? That's the first thing. The second thing is there's a proof on this test that I did not include in the review. That's why I had you guys do fill out all of these terms and give an example. You want to give a numerical example of each one of these. So define Pythagorean theorem and then be able to do a numerical, so like a number answer, and then also a letter version of that, so, or a variable version, would really help you on your test. So I'm expecting my students to fill this whole thing out and also fill this out. Okay? So let me know if you have any questions. Otherwise, good luck.